In this video 6.4, we're going to be looking at applications of linear systems. By the end of the video and work time in class, you should be able to say, I can choose the best method for solving a system. When choosing your method, if it's graphing, that's when you want a visual display of your equations or when you want to estimate a solution. With substitution, when one equation is already solved for one of the variables, or when it's easy to get one of those variables alone, that's when you would use substitution. And elimination is what you would use when you have coefficients that are the same or opposites, and then it's really convenient to eliminate those right away instead of like graphing or substitution, then that would be quicker. You know, and if graphing and substitution seem more difficult, I would say elimination is the easiest one to work in a system. And so what we're going to be doing in this video, I'm going to go over 3 word problems, set the system up, and then we'll solve those systems using a method that we think works best. In class, then we're going to be working on more word problems, and I will definitely help you as we're setting up these systems from the word problems in class. In this first one, a carpenter makes and sells rocking chairs. The material for each chair is $22.50. The chairs sell for $75 each. If the carpenter spends $420 on advertising, how many chairs must she sell to break even? And so we know it's a system. We need to come up with 2 linear equations. In this problem, the 2 things we know are the expense and the income. The expense is y equals $22.50 per chair, x, plus $4.20 for materials. The income, the money being brought in, the money, is $75 per chair. So where x is representing chairs and y is representing money, dollars. So we have expense, we have income. When solving this system, I see right away my y's are both isolated, so I'm going to use substitution. If y equals 22.5x plus 420 and y also equals 75x, I'm going to set them equal to each other because they're both y. So we have 22.5x plus 420 equals 75x. I'm going to start by subtracting 22.5x from both sides. That simplifies to 0, so I'm left with 42. Or I'm sorry, not 42. This is supposed to be 420. So we're left with 420 equals, this would give us 52.5x. And then divide both sides by 52.5. And when we simplify 420 divided by 52.5, we get x equals 8. So 8 chairs is how many chairs she must sell to break even when her expense and her income is the same. A scientist has a container of 2% acid solution and a container of a 5% acid solution. How many fluid ounces of each concentration should be combined to make 25 fluid ounces of a 3.2 acid solution? So we have 2 solutions, x and y, and when we add them together we want 25 fluid ounces. So there's our first equation. Our second equation, we have a 2%, so I'm going to write that as a decimal. 2% of one solution. When we combine that with a 5% of the other solution, we want to make a 3.2%, so as a decimal, 0.032 of our 25 fluid ounces. So there is our second equation. So now we have our system. Our first equation, it's really easy to get one of the variables all alone. So I'm going to get the x all alone. So x would equal 25 minus y. So if I'm saying that the x right here is 25 minus y, I'm going to replace that right here in the other equation. So I'm going to use substitution. So we have 0.02 times 25 minus y plus 0.05y, and that equals 0.032 times 25, which gives you 0.8. We're going to distribute. So then we're left with 0.5 minus 0.02y plus 0.05y equals 0.8. Subtract a half from both sides. And we also need to combine our like terms here. If we combine negative 0.02 plus 0.05, then we're left with 0.03y, which would equal 0.3. Divide both sides by 0.03. We're left with the y is 10. So if y is 10, that's our 5% solution. So our 5% solution, we would need 10 fluid ounces. And then our other solution, x, which is the 2% solution, we know up here, if we come back up to this, if y is 10, then our x would have to be 15 fluid ounces. In our third word problem here, it says the speed of a kayaker is 5.75 miles per hour paddling with the current and 3.2 miles per hour 3.25 miles per hour going against it. What's the speed of the river current? So we've got speed plus the current. You're going to go quicker with the current. That's where you get the 5 3/4. But then when your speed, you're going against it, it's more difficult. You're going to be going slower at 3.25. So with it, you add the current. Against it, you subtract the current, and there's our system. In this one, I would use elimination. Specifically, I'm going to just add the 2. And when I add the 2, s plus s gives me 2s. C plus the opposite of c, there's my elimination. 5.75 minus, or plus 3.25 gives us 9. So if I divide both sides here by 2, the s is going to give us 4.5 miles per hour. So that's our speed. We have to figure out the current. So it says that our speed, we can use either one. I'm going to use speed plus current is 5.75. So we know speed is 4.5. So 4.5 plus the current, my first equation I wrote in my system, is 5.75. If I subtract 4.5, that river's current would be 1.25. So the current's 1.25 miles per hour. And like I said, I will help in class setting up those systems from the word problems. Can you say I can choose the best method for solving a system? Write a summary and reflection and be prepared for the work time in class.